Hello, everyone. Thank you for coming to this breakout session, and I'm really excited to have you all in this conference room. And we'll explain about the details of making OTT services using AWS services. So, everyone is interested in IoT and machine learning and deep learning, so we have a very small number of people, but still it's okay, yeah. So today's agenda is I'll briefly introduce the AWS services for media, and then definitely we will hear from the real customer about the real customer story. So how to build the how to use CloudFront for content distribution, or how to utilize Elemental Cloud for distributing more than 65 channels, live channels, and thousands of VOD files. So we have been talking about the AWS capabilities for media industry for past several years. So we will work with our key customers in every workloads, the core media workloads. So for example, editing and VFX and post-production and DAM and media supply chain. But we will talk about the OTT service today. So what is the benefit of AWS for the OTT service? We can say a couple of things for this purpose. So the first thing is absolutely move faster. So now the competition is very severe in the OTT service market. So for example, in Korea, Netflix is already a number 3 OTT player in Korea. So it has more than 300,000 of subscribers in Korea too. So they're expanding very fast worldwide. So the competition is the first one, and the OTT players should move very fast in this area. So to support those agility, the AWS platform is the perfect place for building the OTT services because we have many good, components to be utilized in OTT service build up. So another thing is try every idea. So we have so many good sessions in this reInvent about machine learning and deep learning and artificial intelligence. So we have several AI services like recognition and LAX or something like that. But recognition is heavily used in the OTT service in these days. So we can utilize those cutting edge technologies into the OTT services too. And AWS is very good at integrating those services, and it is a very good place for building up those services. And another thing is scalability. So yeah, the massive scalability of AWS is a real benefit for the customers for building up the OTT service. So we will talk about shortly about this stuff. And another thing is then we can get rid of undifferentiated heavy lifting a lot and invest in content. Content is another keyword for the OTT market and overall media and entertainment market. And I just told that AWS has full set of features for OTT. The first one is file transcoding. We have Elastic Transcoder and also Elemental Server in 3 formats before. So Elemental Cloud, and we can provide the appliance devices to on-prem. And another thing is the VMware image. But now, yesterday, we announced 5 new AWS media services, and AWS Media Convert is the perfect cloud version of Elemental Server. So we have now a couple of file transcoders on AWS platform. And for the live transcoding, we have Elemental Live on the cloud and on-prem. And also we added AWS Elemental Media Live yesterday. So it can be easily used in AWS console. And definitely billing is consolidated to AWS. It's a real benefit for the customer. And definitely we have Route 53 for content distribution especially. We have Route 53 has many features, for example, geo routing or something like that. And, and also we have AWS media package for making the origin for the media service and integrating DRM services. And definitely we have CloudFront. Now the number of edges are increasing very fast. Now we have more than 100 edge locations worldwide, including the regional edge caches. So the regional edge caches, last year we announced regional edge cache in reInvent, and now that's the good solution for the latency of long-tail content, especially for VOD distribution. So yeah, definitely we have CDN services. And another thing is security features of CloudFront and other AWS services. So we can utilize AWS Shield for protecting the DDoS attack. And we can utilize web application firewall, AWS WAF, for protecting the OTT service. And definitely we have computing resources, various types of computing resources. We have EC2, and we have, it is very natural to run the container services like Docker on AWS. And we have Lambda at Edge too. And storage services. S3 is the core of the media services nowadays. And so many serverless components. Step function is very good for making the workflows, media workflows on AWS, and DynamoDB, SQS, yeah. And from the last year, AWS, especially AWS Solutions Architect team is continuously publishing the best practices architecture through AWS Answers homepage, right? So you can check this well-architected live streaming on AWS from that website. Actually, that is the part of AWS Answers. And you can easily start with a CloudFormation template. So in this diagram, this is a very common pattern of making the live streaming services on AWS. So we are using Elemental Live Encoder on Elemental Cloud. Actually, it is running a different VPC from your VPC. But anyway, it is running on top of the AWS. So the content is ingested to Elemental Live Encoder. Then Delta can do some more stuff like DRM processing or something like that. And if we think about the scalability, we can add some proxy layer. In this diagram, we are using Nginx proxy. That is very useful, especially for making multi-CDN environment, because it can give you the scalability factor for the media services, live services. And we have another reference architectures for handling the VOD workflows. This workflows is quite new, and we used step functions to make the workflows, actually. So step functions is a combination of a couple of Lambda functions. So it is handling the ingest and validate the ingested content and extract the metadata and store those metadata into the DynamoDB table. So it is very automated. So if you just upload the content to the S3 bucket, then every processing is done without your intervention, and the deliverable content will be stored S3 again. And then you can utilize CloudFront. And it is easily integrated to your CMS environment. We can utilize SNS or other AWS services to do that. Now, this would be the strategy to building up OTT services on AWS. So you can quickly start from AWS CloudFormation template through AWS Answers homepage. We are providing the manuals too. And this is very interesting. So innovation through AI services is very easy on AWS. So actually, we published another CloudFormation template utilizing AWS Amazon Recognition. So we are extracting the thumbnails from the video, and then we are running the recognition against those thumbnails. Then we can extract many information like face recognition and the sentimental analysis for the people in the photo. So we can utilize those information as another metadata for the video content. And definitely, we have many CI/CD components in AWS, AWS code pipeline and code build, so many stuffs. So you can easily accelerate your development cycles. And yes, easily build global services using AWS Edge services. Definitely true. And S3 is really important service for media and entertainment customers. S3 is the real data repository for media services. And another thing is we have more and more customers really want the personalized content consumption, right? Netflix is always giving the recommendations for each subscribers. That is very important. So we can utilize S3 as the storage for those information, and there are so many computing engines using those data. Okay, now it's time to introduce Korea's #1 OTT player. So the POOQ is actually the #1 commercial OTT player in Korea. And let me introduce the CTO of Content Alliance Platform, Felix Cho.
Hello. Thank you, Gyeon. Okay, before start, apologize if my English is broken because English is not my mother tongue, so maybe my expression is a lot, but please bear in mind. I'm responsible for handling the technical side of the POOQ, the Korean OTT service, and I will be presenting how our platform get evolved with the cloud, especially with the AWS. So let me start with what POOQ is. POOQ is an OTT provider. I think everybody knows the terms of OTT. You can think of a smaller version of Netflix. That is what I'm thinking myself. This is actually a joint venture between all three terrestrial broadcasters in Korea, which was very unusual. Normally, they are actually fighting for the ratings of the program, but now because it's more like a end of era for the terrestrial broadcasters, so they decided to make some kind of an internet service arm so that they can find a new market on the internet. So that's what my company started. Founded at 2012 May, which is not that long, and we are serving as of October. We have a 64 live broadcasting, which is a little bit unusual for the OTT. Usually OTT is more over the VOD service, but we are providing live service as well, which means we are like a 20-second delay from the real broadcasters. Over 160,000 VOD streaming contents are there. Most of them comes from these three companies, but not every one. We have other CP's contents as well. And we have 6,000 movies, including some latest Hollywood movies, because the Koreans, they like to watching the movies over internet as well. And because of the kind of high demands, actually Hollywood movie companies are providing us new latest movies over internet streaming, of course, protected by DRM. We have this number is a little bit old, but as time of writing, we have 620,000 paid subscribers. That's a very small number compared to Netflix, I know, but you have to understand that our population is just 60 million people. So that's not comparison. And average price of the USD is USD $9 per customer. So that's our revenue. You can calculate that. And we have about 3 million registered users without paid subscription. We also provide some kind of ad-based streaming. So these guys are actually not paying money, but watching the advertisement during our service. And as he introduced us, we are #1 player on Korean OTT market, largely because we are the content provider. So it's a very unique situation. You can think of in terms of the Hulu, in terms of the relationship between the content provider and the service provider, because we are wholly owned subsidiary of these broadcasters. So guess who's their favorite streaming service provider, right? Let me briefly introduce what kind of UI we have. I'm going to have a couple of slides here. I'm not going to tell everything in detail, but just to give you the idea of what we are doing. This is actually PC screen. That long, hideous kind of left side image is actually full screen captures. And that is composed of a lot of elements. So let me just quickly cover that. On top of that, that is a VOD, my watch list, which means that we have compiled this kind of list for just you. And this is what you've been watching for last day, few days or something. And second is my channel list, which is similar to the VOD, but this is actually live channel. So if you watch some channel, your channel will appear in here so that you can find your channel very easily. And last one is a popular list, which is compiled from the statistic data of how many people is watching what, and we are providing that. Second is a curated list of the movie list. You may think this is an automatic AI kind of thing, but that's not this is. Actually, this is good old hand-picking service list. That's because some of my colleagues inside my company prefer having a hand-picked content so that they can place their marketing pushing contents at the first time. So I'm not a big fan of this kind of approach, but these kind of things happen. And the popular channel list is the same thing as a VOD list. And there's the curated special token, latest list, home shopping kind of thing. A lot of contents here. So you can just understand look at just the pyramid, what kind of things we have. And please understand that all this data have to come from the server to the client at the same time. So you may think about, wow, how many API calls should we have? At least we have, actually we have like a 28 API calls for the creating these first pages. This was happening, causing a lot of problems for us. Now we are actually getting pretty decent response rate, and I will explain later. So that at the end of time, actually there's the black bars on the top, bottom of that. That is actually what we call the continue watching. Which means actually if you watch some contents on your mobile phone, and if you just turn off the mobile phone and power up the PC, your PC will tell you that would you continue watching your contents which you were already watching from the other devices. So this is a true end-screen continuous watching solution service, so that whenever you switching your devices or even turning off your mobile phone and turn on, you can go back where you have been watching. This is actually a feature of the Netflix is using for a while, and this is actually our first, Korean-owned the first technology availability for that kind of solution, what we are providing at the time. Okay, for the viewers, you can say this is pretty much standard viewers, right? And there is actually scene detection, scene thumbnail browsing, and that 10-second back and pause, and a lot of things pretty common. But there's one more difference is one more different service were there, but I will tell you later. And we have on multiple devices. We have a PC web, mobile web, Android, and so forth. Funny thing is actually you can see that there's a Samsung Smart TV app and LG Smart TV app. Those are not Android apps. Actually, for the Samsung, that app is actually on top of the Tizen operating system. And for the LG, that is on top of the WebOS. So we had to build all of those because our customers demand this kind of all kinds of different things. But you may not find the Apple TV on here because Apple does not sell the Apple TV on Korean market. So some of our colleagues are dying to have an Apple TV up and running, and they even made their own prototype by themselves. But we are not selling because there's no device here. A little bit of shame. Okay, I will tell you about the platform evolution history because I was thinking that what better way to say that why we are getting a lot of help and why we are getting very comfortable about the current situation is because maybe we have to start from this earlier time at our system. Our platform was not based on the cloud. Believe it or not, that was happening, and we had a lot of problem with that. And let me give you a little bit of story about what our platform has happened. Initially, May 2012, there was a POOQ 1.0, and if you just check the graphics of the presentation, you can probably left by yourself, because this is more like a pretty much a standard three-tier web service, which I don't think you guys ever using anymore, because that's pre-cloud, pre-everything. But that was happening in the POOQ 1.0 because that was the technology approach at the time, which was not part of myself because I was not there, and this was before my time. The funny thing happening is actually, if you look at the slide, there's an ASP.NET web server and mobile API server as a Java, which is odd. Why you choose two different technology? And you are talking about just a handful of engineers in here. That's because initially, two broadcasters sent their engineers inside our joint venture. And one guys preferred the .NET, one guys preferred the Java. They could not agree on anyone, so that they decided made their own. I see the smile faces, and you can imagine the pain that I was having. So that problem is, because of these kind of two companies came together, from the starting of the company, we have to expose ourselves to the polygraph situation. I'm sorry. So initially, this service initially proposed very well, which means the paid user was less than 10,000 people, 20,000 people. At the time, at that kind of a scale level, it works well. So people was happy about it, and marketing guys are demanding a lot of marketing service on top of that, and a lot of new service on top of that. But it gets started exposing the problem when our company became the bigger in terms of the service customers. We have a famous, very famous entertainment show in the Saturday. The problem became that whenever that entertainment show became live, remember, we are serving live here, right? Everybody's customers jump into our system within like a 1 or 2 minute period. That caused our problem. Usually, it goes after crashing the server and saturated the database resources and everything. So we had to change and reboot the system and do the thing and here and that. But nothing can make sure that kind of a death of the service are preventable. So database resource gets saturated. Local cache has a limitation, which means it's not that good. And surprisingly enough, again, I'm emphasizing myself that this was my pre of my time. They were not using any source control system. I cannot imagine why, but they didn't. So what they done is they actually changed the source code on top of the servers, running servers, and hopefully it syncs everywhere. And everything was real, which means that there's no staging system, there's no testing system. What the developers done is actually developing their own software on top of their PC and just roll out. And as I already told you, there's a ASP.NET and the Java server problem, which means a different group of developers are working on different system, which means sometimes Java and the .NET will act differently on the same functionality. So that causes a lot of headaches and things like that. Scaling problem has a problem, huge problem here. And at this time, we were using real servers. I mean, I think it was actually 16 servers on the some kind of a data centers, and they were actually operated by some operating companies that work for us. And that means that we have a scalability issue, heavy scalability issues, which means that we are just bound to the 16 servers, and we are trying to do our best to make a maximum utilization of that, which means that we have no luxury to look into the personalization and everything. So it was almost like a prehistoric system. The POOQ 2.0 is actually my engagement to this company, and this was done after June 2015. This project was started in November 2014, so not that much time has gone into preparing this platform. But anyway, this goal was, A, it should be cloud, and it should be die-hard platform, which means we had suffering too many system breakdown, so dying hard was the primary goal. And we badly wanted to have a personalization and API unification. So API unification is a very old item of list, but having a Java and a .NET, that is actually one of the goals. So what I designed was actually, as you can see, we still have an MS SQL database, but we are not using MS SQL database as a running data source. We are using MongoDB, and we are using Cater ETL data transfer solution, which is open source, initially from the Pentaho. Now I think it's a part of the Hitachi. We are using lot of ETL script to extracting the data from the MS SQL to the MongoDB. So whenever the actual server is running, we are using MongoDB. And as you can tell, MS SQL has maximum of 2 servers per one instance, but the MongoDB can go up to as high as what they claim is a 50 or 60. But we are using actually 13 servers per the one single data sources, which can achieve the more higher and more resource to the simultaneous users. And we also using the Cassandra database to collecting the user behavior data. I think I will be explaining later, but the user behavior data collector means that whenever our customers are streaming something, live or the VOD, we are collecting their statistic data, like who they are and what kind of VODs, what kind of contents they are seeing, and where in sense of time they are watching. So that we are collecting whole data in the Cassandra DB, and we are using Spark analysis for the more recommendation calculations and things like that. And we have a Mongo database about the data mat. But still, in this case, the CDN and streaming headend and the media ingestion was outsourced. I mean, at the time, we didn't have any resource to make it in-house, so it was actually outsourced to some kind of some local CDN provider, which is not cloud. But that was the time when we have we didn't have AWS Korea region at the time, so we had to rely on that. And hold the API unification we achieved with Swagger. So now we are using heavily on the YAML and the Swagger kind of the approach to the API specification. And we are using their automated source code generation. We have written our own custom source code generators, so that everybody, if you want to implement some API, you have to write a YAML, and our tool chain makes your the first template code with a mock data as well. So that right now we have a very shortened in time to create some API to the real-world service. Let me give you a little bit of detail of POOQ 2.0. This was the first attempt from IDC to cloud. So this is a cloud system for that. 2014 and earlier 2015, we moved to the cloud. It was not AWS because at the time, there was no AWS Korean region was there. The closest region was Tokyo. But problem is, if you read Rex Ride, there's a Korean privacy law, very strange law. But anyway, if you move your customers' personal information over cross-border, you have to get approval from each of the individual customers. That's a very old law, but it is still the law. So we are not able to using the Tokyo region because we already have a lot of customer data. So I had to stick with the local. So we use the local cloud for the 2.0. It scales well. We tested over 500,000, but the actual workload at the moment, up until now, is actually highest score was 280,000 users simultaneous. And I can tell you a little bit more about later. It has finally what marketing guys want: the personalization, user analysis, recommendation, and cross-device streaming region. So it looks like OTT platform, not not 100% perfect, well made, but at least it's working. And we have API unification based on the YAML and the auto source generation, which means we are creating the specification from the language neutral way based on YAML, so that that source code translation tool will be creating the Java and .NET, so there will be no discrepancies on top of that. Okay, API unification is done with the Swagger base, and we have a GitHub, and we are using the Jenkins CI, so everything getting automatically, and there's a mock data versus real data, which is very useful for creating the API-based system. So every time you create something, there's always the mock data, so that the client can start right away without servers finalization. Also, we have experienced the migration from RDBMS to NoSQL, which means we were actually bounded to the how powerful one MS SQL DB was. Now we are bounded to the multiple MongoDB, which is quite scalable to my understanding. And that's much better data resource bandwidth, so that we can do more and we can provide more data without losing too many time problems. We are very happy with the ETL tooling. If you guys do not know that they are Cater, I think I recommend you to look at it, because Cater solves a lot of our problems without too much hassle on creating the source code itself. So basically, that's a lifesaver if you want to transfer some data from A to G, or in our case, we are using Cater data batch scheduler for every 10 minutes, so that we are keeping the sync from the MS SQL and the Mongo data. User behavior data collector is what I told you before, the proprietary implementation of the collecting the user data. Is for every 10 seconds, which means actually your streaming resume will be last some kind of a checkpoint of within the 10 seconds, so that you can resume your pure. This is not a word first kind of thing, but this is a workable scenario. And thanks to the Cassandra, we have a scalability for doing that. The 7 terabytes is typo. I don't hope, I certainly do not want to give you the wrong impression. What we have is actually 120 gigabytes per day of data collecting to our Cassandra, and we are backing up to the S3. So that Cassandra has like a 60-day data retention, and after that, every data is stored in the S3 for up 2 years. That's our primary data for the next one, the user analysis. We are supporting the recommendation based on the user Apache Spark ML library, which was available at the time, because that was 2015. TensorFlow or MXNet is very less known to the others. And service analysis is actually what we have done so far is because we have a lot of user behavior data, we are creating various kind of reports, whether marketing guys or the business decision guys want, like what kind of contents are famous for some specific time, is the mayor between 30 to 40 have which kind of contents in their personal best, and what kind of things the kids want, and what kind of the contents provider are performing best. So that kind of whole data is generated based on that user behavior data, and we are using primarily on the Apache Spark for that. This is actual MRTG graph I captured from the actual happening. This was actually, I'm not sure you guys are familiar with that, but that is a world baseball classic kind of a world premier baseball games between countries. And that was a semifinal, and that was between Korea and Japan. That spike at the end of the graph is actually end of 8th inning. That was when we were losing. I mean, Korean was losing, but some guy hit a rather, very good home run, and we actually overturned the result. And as you can see, people pouring in very fast because they just, seen from the SNS kind of message, and they come into our service. And at the time, we were serving 551 gigabytes of CDN data flow simultaneously, and that was actually 280K users. So this was actually our highest users in terms of the real situation. For this year, February, we migrate to our service to AWS. Two reasons, because there was AWS Korea, so we were preparing to migrate those platforms to AWS. Other reason is that we have, the local guys could not support some functionality what we want. For example, we were actually thinking about migrating into the Docker. The problem was the local guys providing Linux was a little bit old, so they could not provide the Docker functionality. So that was actually primary reason. And other reason is actually, AWS has much better scalability and the API service and CLI and a lot of things. And also, our developers dying to want to using the AWS rather than the local one. So we decided to move it. Took a month for migration, and most of the time consuming task was how, the data migration, which means actually we have a lot of data over the user behavior data, so that we start to migrate that data, and that took a month. But having, our servers installed into AWS, I think that just took 2 weeks, because it was very easy one, I think. Okay, let me go to just the sideway, and now I'm talking about the head ends of platform of the AWS. So what we refer to the head ends is actually, up until my presentation, we were outsourcing our CDN and the media streaming, even though we were at OTT. So by starting of the November 2016, we start operating by our own head-end system, which is hosted in AWS. And this is actually, we decided AWS because there's a business and functionality requirements to have our own head-end, and that AWS can support this kind of system. We need to prepare the UHD 4K readiness, because Koreans already started broadcasting the UHD. And we are supporting protocol of HLS and the Epic Dash. And we also supporting the AVC and HEVC. HEVC is being tested for the UHD contents, and H.264 is primary using for the VOD. We also supporting the multi-DRM. This is due to the fact that the Apple device only supporting the Fairplay, and Android supporting the mobile wideband kind of situation. So we have to end up supporting these 4 DRMs all together, and we are supporting the VR streaming. So this is a specification of the we are using at the moment. So we start regionally the 360p to all the way to the 1080p, and we are using the H.264 primary and the HEVC for experimental or less bandwidth consuming kind of situation. Naturally, we are supporting the 25.97 frames per second. This is actually, we are talking about excluding the UHD. So this is the situation. We have a 2-second chunk, and we have a 60 frame GOP closed. So this is our live streaming. Unusual to the OTT, we are supporting the live system. And let's just tell you the situation from live to the web. There's an external live feed of RTMP. This is feeded from our alliance, the content provider, including KBS, NBC, and SBS, which is our parents company. We are using AWS Elementor Live to ingest those streamings, and we are producing the live S3 bucket. We decided to have a S3 in between our ingestion and to the service because we can tweak that and using as a different service rather than a live system. So we are storing every incoming data to the S3 bucket as a 2-second TS chunk. There's a protocol mixers and the generator and so far, and now client can have a live streaming via CloudFront. So what happened is RTMP source, live encoder, S3, and CloudFront. That's our system for the live service. And we have a 64 live service here. And I believe this is our first customer case in Korea to utilizing the live Elementor encoders. Initially, when we start this project, some of the local CDN providers actually came forward to me and concerning that you might get a bad result with the Elementor because nobody's done that, and maybe Amazon is not ready for that, or so forth. I heard a lot of things, but during our testing and evaluating, looks like this is the right choice for that, so that we go for that. Under the hood, there's live encoders and things like that, which I already explained that. And the protocol muxer is actually muxing the HRS data and NPEG everything in together and creating the M3U8 kind of the manifestor data, so that this one can be creating the live M3U8 data. Unlike the VOD, this list will have to constantly updating because of live situation, so that we have this kind of system. We also have a radio channel. The funny thing is actually at the time, as of implementation time, the Elementor Live does not have an audio-only channel. They have now, but at the time they don't. So we had to using some voucher servers to provide this kind of functionality, and now in the process of migrating from voucher to the Elementor Live as we speak. We do have live thumbnail, which means we are actually generating the thumbnail for every content so that we can display the thumbnail on our service and so forth. We also have a very unique service called the Live OnAir VOD. This is something that when the live is starting, after 5 minutes, we are actually providing that content in the form of VOD. So in the customer's eye, it looks like a VOD, but that's still in the live system. This is actually, we designed this because sometimes people do not want to miss the starting of the streaming, but they were not able to meet the time of the starting time. In that case, usually the solution was having the customer to ability of doing so-called the time machine, so that the customer have to slide back a little bit, trying to find where is the first starting. But this is something we done for the customer. So customer can just click the contents and they can watch it as if they are watching the VOD, but which is still live. The trick here is actually number 3. Number 2 and number 3 in the client side. So this client is keep asking, how far can I stream to the server in the 10-second interval? So the server say, yes, you can stream up here, and you can stream up here, and so forth. So that whenever the client, users trying to, scroll the slide bars of the streaming, like as you do in the VOD, you can only able to stream to the certain point, which is live situation. So that is a little bit of a restriction, but other than that, we found that the customers very fond of the idea of having a VOD, even though this is actually a live system. Okay, I think we already found the VOD system. So that this VOD system is actually serving the VOD and movie. Difference is actually movie has a DRM control. Our television VOD does not. And we also have watermarking embedders. So let me tell you a little bit. VOD ingest is just straightforward, HTTP pull over TV VOD and the FTP push for the movie, so it's pretty much basic shit stuff. Ingest worker is actually our own implementation of FFmpeg-based system, and we are using heavily on the spot instance of the Amazon. So what is happening is actually whenever the content is getting ingested, our actually ingest worker can be working as a working as the cost-effective spot instance kind of situation, and we are using the multiple workers per the single contents, and we are combining them all together back. So this is actually our attempt to make a cost saving or the cost-effective data importers here. And VOD S3 bucket means that we are storing everything after ingestion, storing everything into the S3 bucket in the shape of the 2-second TS video. We decided this one because if you recall, what we have is actually elementary encoders and the FFmpeg encoders and the S3 and the CloudFront. So if you want to use the CloudFront as efficient as possible, it is better you have the data source as S3. So all our data is stored inside of S3 as a form of a 2-second TS chunk, so that after that, streaming is actually just HTTP data downloading, nothing fancier here. VOD watermarking embedder, what we have is watermark embedder is because some Hollywood companies demand that when you stream the movie, you better have some kind of user information embedded here, so that we have to make some kind of a 1 and 0 bit invisible to the users, but embedded here so that if there's any kind of leak, people can find out. So we are providing this one, and now we are in the finalizing with the testing with some Hollywood companies, whether they are okay with this service or not. We do have a signed URL generator. Normally, the CloudFront using the sound cookie, but we found out that some of the devices not able to using the signed cookie, so we have to sign supporting the signed URL generator as well. Okay, now is a little bit of behind the story. We are the first Korean customer case for the Elementor Live, and the first time using the CloudFront for us. So you can imagine a lot of hiccups and a lot of problems. So let me briefly cover some of the problems I had. First one is mobile network throttling. As you know, that the mobile company is trying to throttle your data output, streaming output, when you reach certain amount of data transfer per day, right? So all Korean mobile operators are doing that, but one certain company were doing very badly, or very strangely, I should say. The left side of slide is what you are getting normally, having the network bandwidth control. So meaning that every time your throughput is contained within the bandwidth limit, that's what happened. But in the left side, that's some other strange way to control it, meaning that if you send the TS contents in time series, sometimes your TS will get higher bandwidth rates than what they are claiming, but sometimes it gets very low, almost no throttling, no bandwidth. So it makes a huge problem for our customers because a lot of bufferings and everything. So funny thing is we solved the problem after we switched to the HTTPS. So it looks like their system was not sophisticated enough to understand the HTTPS streaming. So now we don't have a problem for that. And also, we after implementing the BBR, this kind of things goes away. Some other thing is actually, we got a call from some government office guys who were our customers. They said after switching our CDN to the CloudFront, they could not watch the VOD. Turns out that after switching to the CloudFront, we were actually controlling which client IP they can stream to the pool IP address ranges. And turns out their government office had a very interesting security measures. So whenever these guys are going to the internet, they are actually sharing some kind of the C-class IP block altogether, meaning your first core will be just end by the 1, or the second thing is going to end by 2 or something altogether. So our IP control scheme was not able to handle that kind of situation. So because of doing that, we had to change it to the restriction to the C-class at the moment. So now actually we are not fully controlling IP, but we're controlling the C-class. Streaming incompatibility is a very interesting thing. As you can imagine, there are a lot of content providers in Korea feeding the data to our server, and we were receiving those data from with the elemental encoders. I don't think it's a problem, issue from the elemental, but some of the data they providing has a problem in the MPEG streaming, not compatible to the standard, or the very bizarre movement for when it comes to the goes down, a disconnection, and a lot of things. Caused a lot of problem for us initially. And thanks to the Elementor, they had to patch rather, I think it's 5 or 6 times, and now everything is under control. But initially that was a pain, quite a pain. And this one is also interesting. Although our client is living inside Korea, although our service is the ICN region, which is AWS local, we get funny things when the clients, from the certain telcos trying to stream. Their stream comes from the LAX, NRT, and HXG. I mean the US and Japan and Hong Kong. This was very interesting, and we were trying to figure out why these things happen. Turns out that some of our local telco had a problem with setting the DNS or the routing situation, which our company or Amazon cannot control. So Amazon has to change or tweak their DNS strategy, and our server as well. And not 100% solved, but now it's getting better and better. And after these guys, after the Amazon has the direct peering to those companies, these problems goes away. So that was other very funny thing happened. So the CloudFront pros and cons. I think the pros is well documented. It's important for us who is not speaking in English as a mother tongue, because normally Korean engineers are okay with reading the English documentation, but not happy with if you have to communicate with in English. So that is a good thing. And in the local engineers gave us a decent, good supporting in general. And first of all, it was a stable and mature, which means if anything is not working, we can start suspecting our code first. That was good, because previous cloud and previous CDN, that was not the case. Usually, they were done something wrong. So that was good. But the cons is actually absence of local support engineer was a problem. I mean, in Korea and US, there's a time difference. So the problem is when we have a problem in the daylight, the American engineers are going home as asleep. So we had to wait a couple of hours to get the answer, and that was a problem. So now I think that the Amazon Korea already hired some engineers and having the training for that. So I think hopefully that can be better. Final thing is actually worst for me is actually lack of notice or announcement of their software patch. Elementor and Amazon is keeping their service upgraded, and they are patching every time. But sometimes with a certain patch, we get a problem. But since we do not know when that is happened, we had actually 2 major problems. Later found out that that's happened because Amazon guys are patching something which is not compatible to us. So I was very curious about this one. I had a lot of conference calls and things like that, and asking Amazon guys to please have at least some kind of bulletin board, so that at least we know when it's happened, so that we can monitor that. So far it's not happening, but I'm asking right now again. So hopefully, fingers crossed. Okay, next thing is the POOQ 3.0 and the UHD and beyond. This is something in the future, so I'm not going to get into detail because it can be changed. But anyway, this is a POOQ 3.0. Major difference from 2.0 is actually now we are using Kubernetes and the Kong API gateway and Docker as a microservice. That is actually happening right now. And we are still using MongoDB, and now we are incorporating Apache Kafka as our message brokers, switching from our proprietary system to our new system. And we also have the head end. So Docker-based microservice, I think everyone knows about Docker-based microservice, so I don't think you're going to need any introduction. But interesting is, since still our company is still the polyglot situation, everybody keep fighting about Java and .NET still. So we come up with you can either develop in the Java, C#, JavaScript, Python, and Golang. So anything within this list, you can develop your own as a microservice, and we are not gonna, code review inside your code, but we're gonna testing input and output, and if it fits, then is it okay? That's our policy. Kubernetes, we were struggle between the Docker Swarm and Kubernetes and ECR, and we decided to using the Kubernetes because the operation guys think that this is the best suited for our needs. Kong API Gateway has some interesting story. Initially, we were start using the Amazon API Gateway. Funny thing happened is we hit the maximum of the 50 LBs per VPC. That means you cannot have more than 50 LBs per one VPC. That is not the case at the moment because a couple of weeks ago, this restriction have solved. But at the time we were studying, this was a big problem, which means if you're using the Kubernetes with the VPC and API gateway, you can up to 50 APIs per VPC. It's a big problem. So we did not know that when we started that, but we now realize that this is a problem, and we had to go back and trying to look for the alternative, and now we are using the Kong. And although this is not finished the project, but we are moving forward so far, so we were not able to go back and try to using the API gateway again. But like I said, this 50 LV limitation is already lifted because of this kind of situation. So if you go for the API gateway, I think this is okay for now. Apache Kafka message broker is too famous, so I don't need an introduction. So we are collecting all the user data and everything in the Kafka, and we are using everything for the Kafka. Marketing campaign design engine means that we are creating our own custom rule-based marketing service or marketing analysis tools based on the input from the Kafka, so that we can monitor your login, logout, purchasing, clicking, everything. So that this will be our next generation of the marketing tool system. And the data analysis engine, we start using the data lake concept, which means that we are storing everything with the S3. Actually, what we are doing is we start using the AWS EMR, and we are storing the data as a Hive form on top of S3 so that we can have up to the 2-year retention. Initially, that was not possible because of the price problems and the budget problems. Now we can. And integration of machine learning, of course. We are still in early age and long way to go, but right now what we have is a scene keyword detection, which means we are feeding lot of thumbnail images to the recognition engine so that we can get some kind of a scene detection data like snow, beach, or car or something like that. Then we are using that as a base of our recommendation data. And we are also working for the celebrity face identification so that we can have a better casting information of our VOD data. Problem is, the European face detection and Asian face detection has a little bit of different result. So that now we are trying to look for the better situation for the face detection, but it's not done yet. And initially, we are going to outsource the online service for between the AWS Recognition and Clarify. We are still testing those two roads, and we will be having some meeting with the AWS guys for this after this session. We may have to choose, or they're going forward from there. UHD, we are having an ETA of February 2018, and we're going to have a Super 1080 and the UHD 2160p, and we are going to using the HEVC, and the higher speed rate will be 15 megabits, and the frame rate is, of course, is 16 FPS. UHD Live, we have to using the on-site live encoder because at the moment, to my best knowledge, the elemental encoder in the cloud doesn't have a power to produce the UHD streaming. So that we have to purchase the elemental box for each CP, and we are going to get the TS data over S3. So that is a little bit of shame, but I believe that in the future, next version of the cloud, maybe these guys can come up with a better solution for that. Okay, so beyond that, what's next? We are looking into HDR support because it looks like the POOQ is already gone and HDR is coming of age. So we are looking in that. And we are also looking into the AV1 codec, which is not commercially available yet, but we are looking for that. And we are going to keep working on the POOQ 3 enhancement. And we are really wanted to bring a machine learning inside our office, but our resource has a limitation on that. And request for AWS. AWS is a faster CloudFront for UHD streaming. Okay, thank you. Thank you for the time.